All right, now in this question we're asked to determine whether the mean value theorem applies to the given function f on an interval a to b given below. And if it can be applied, find a value of c on the open interval from a to b where it does apply. Well, now in this case, let's make sure we know what we're all talking about right here. We're talking about a being 0 and b being equal to 1, and we want to determine, first of all, whether it meets the conditions for the mean value theorem to be true. And the conditions are that, number one, is f of x continuous on the interval, including at the endpoints? So is f of x equal x to the 2/3 continuous? And the answer to that one is yes. It is continuous at all points. And the way that we know is that at all points c on the interval from 0 to 1, including at 0 and including at 1, we can say that f of c is defined. We can say that the limit as x approaches c of f of x always exists, and that the value of the function at any point c within that interval will always be equal to that limit as x approaches c of f of x. So in other words, it meets all three conditions at every single point, including at 0 and at 1 within this interval. So the second question is we ask, is f of x differentiable on the interval between 0 and 1? Not at 0 and 1, but between 0 and 1. Well, f prime of x in this case, by our power rule, would be 2/3 times x to the negative 1/3. We subtract 1 from 2/3, we get negative 1/3. And this is like saying 2 over 3 times x to the 1/3. Well, there is a point where this function's derivative does not exist, and we would say that it does not exist at x equals 0. So f prime is not differentiable at x equals 0. But does that really matter? Well, no, because we're interested in whether or not it's differentiable over the open interval from 0 to 1. So we don't really care what happens at 0. So therefore, our answer has to be, in fact, that yes, it is differentiable, and so it meets those two conditions. All right, so what is our next task? Well, our next task is to figure out a point, c, on the interval such that the derivative, when we evaluate it at that point c, is equal to the value of f of 1 minus f of 0 divided by 1 minus 0. In other words, the difference of f of b minus f of a over b minus a. So f prime of c in this case is going to be equal to f of 1, well, that's 1 to the 2/3, that's 1, minus f of 0 minus 0 over 1 minus 0. So we actually are looking for a point where the derivative is equal to 1. Well, here's our derivative over here, so we want to find a place where 2 over 3 times x to the 1/3 is equal to positive 1. Well, we multiply both sides by the LCD to get rid of the fraction right here. I can just tell you it's 2/3 is equal to x to the 1/3. I'm just multiplying both sides by x to the 1/3. And then if I take my cube root of both sides, we could say, well, x is equal to the cube root of 2/3. Now, does that fit within our interval? Well, absolutely it does. If I take my handy-dandy calculator and take 2/3 and take the cube root of that number, here is my cube root of my Windows calculator, 0.087, so approximately 0.87, this is true, and therefore, yeah, f of x is differentiable, and there is a value of x for which the derivative would certainly equal to the slope of the line secant to the curve through those two endpoints.